All right, today we're going to focus on solving three variable systems with elimination. When you are working with elimination, the first thing you're going to want to decide is which variable are you going to eliminate. You want to see which one's going to be the easiest in all three variables, in all three equations. If I look at this one, there's a -2, a -3, and 2 as coefficients on the x's. Those are going to be easy to work with, but not as easy as some of the others. I look at the y's, and there's a +1, a -1, and a +1. I don't think it can get any easier than that. They all have the same sign, and then we've got a different sign right here. I'm sorry, the same number, and then we've got a different sign right here. On z, we have a 2, a 2, and a 1. That would also be easy, so this would be the second easiest. Y is definitely going to be the easiest, though, so we're going to do that. It doesn't matter which variable you pick. You're still going to get the same answer at the end. It's just going to make it a little bit harder as you proceed and more steps. So we're going to go ahead and pick the y. Since they already, I'll start with the first two, and since they already have the same coefficient with a different sign, I am ready to go. I don't have to change them at all in order to add and eliminate. So I'm going to move my equation over here. When I do that, I get -2x minus 3x, which is -5x. Y and -y is 0, so that is gone. And then 2z and 2z give me 4z. And -3 and -11 give me a -14. I've now created a two variable equation here. In order to create the two variable system, I need another two variable equation. And I've got to use all three equations from the original. So I need to use this last one now with either one of these. I can pick which one. I'm going to go ahead and pick the second one because it's got a -1 coefficient on the y, and this one has a +1, so again, I don't have to change them. So I'm going to do these two for the second portion. I'll bring it down here so that we can line them up. Now I'm ready to eliminate. So I'm going to go ahead and add these two equations together. -3x and 2x give me a -x. -y and +y is 0. 2z and -z give me a z. And -11 and 8 give me a -3. So I've created another two variable equation. So now we have a two variable system. When I put those together, I've got -5x plus 4z equals -14, and -x plus z equals -3. We are ready to go. At this point, you can do substitution or elimination or graphing or whatever method you use to solve a two variable system. I'm going to go ahead and do elimination again. Both of these have a coefficient of 1, so really either one of those would be easy to eliminate. I'm going to go ahead and eliminate the x, so I'm going to multiply this bottom times -5. That will give me the same coefficient with a different sign. So -5 times -x gives us a +5x. -5 times z gives me a -5z. And -5 times -3 gives me a +15. The other equation is just going to move over. So we get -5x plus 4z is equal to -14. We're ready to add these two together. -5x and 5x is 0, so that goes away. -5z and 4z gives me a -z. And -14 and 15 give me a 1. Not quite finished yet because we still have this negative in front of the z, so I'm going to multiply those both times a -1. And so we get z is equal to -1. You don't stop once you have one variable. You want to make sure you go back and get the others. So I need to take that and plug it into either one of these equations to get our x value. So I'm going to plug in -1 for the z here. So we get -x minus 1 is equal to -3. Now we have that z is -1 and x is 2. We haven't finished yet because we need to find the x value. So we're going to take these two and plug it into one of the initial equations up here. You can pick any one of these three. As long as you do it correct, you're going to get the same number. So I'm going to go ahead and pick this bottom one, and I'm going to plug in the 2 for my x and the -1 for my z. So here we go. I get 2 times 2 plus y minus a -1, so that turns into a +1 there, is equal to 8. 2 times 2 is 4. I add my like terms and I get 5 plus y is equal to 8. And now we subtract the 5 and we get y is equal to 3. Now we know what x, y, and z are. Remember, when you put those as an ordered pair, you start with the x, so that's 2, and then the y is 3, and the z is -1. So that's x, comma, y, comma, z. We have solved that with elimination. All right, we're going to go ahead and try another one. Remember, first step is to determine which one of these you want to go ahead and eliminate. You're going to want to think about what you think is the easiest. So we look at those coefficients. I think the x is going to be the easiest here. Those are the ones that are going to make the same coefficients with a different sign the easiest. Here we've got a 2, 5, and a -1, so we're going to have to do more work. Here we have a 1, a 4, and a -9, so we're going to have to do more work. So the x's are going to be the best to work with. I will start with my top 2 equations again. In this case, I am going to have to multiply something to get the same number with a different sign. This is already a 2, and this is a coefficient of 1. So if I multiply this top one times -2, then these would cancel. So that's what I'm going to do. I'm going to multiply that times a -2, and I get -2x minus 4y minus 2z is equal to 0, because -2 times 0 is 0. It's one that we see often messed up. The other equation is going to be moved over. Now we are ready to add those two equations together. -2x and 2x is 0. -4y and 5y is y. -2z and 4z is 2z. And 0 and -1 is -1. Now I've got a 2-variable equation. I have to do the same thing now using that last equation. And again, I can pick either one of those to use. They already have the same number on the first and the last one, so that's what I'm going to use, that first and last one. And I can multiply one of them times a negative to get the different signs. So I will keep that first one and multiply the last one times a negative. So I get a -x plus y plus 9z is equal to a +5. I've multiplied -1 times each one of those to get this new equation. And I'm ready to add. X minus x is 0, that goes away. 2y and y give me a 3y. Z and 9z give me a 10z. And 0 and 5 give me a 5. Now I've got a 2-variable equation. I'm going to rewrite them together. There you go. Now it's time to go ahead and eliminate or substitute again. Again, I think it's an easy one to eliminate. I can go ahead and multiply this bottom one times -3, and my y's will eliminate. So that's what I'm going to do. I'm going to multiply that times -3. -3y minus 6z is equal to 3. The other equation, I just bring it over so that everything's nice and lined up. And here we go. -3y and 3y is 0. 10z and -6z is 4z. And 5 and 3 is 8. I divide by 4, and so we found our z is 2. Again, you're not done there. You want to make sure that you go back and find the other variables. So we're going to take this z and plug it back into any of our equations. I'm going to go ahead and plug it into that y plus 2z equals -1. I subtract the 4 to get it to the other side, and we get y is equal to -5. So now I know that z is 2 and y is -5. So I go to one of my original equations. Any one of these will work. So I'm going to go ahead and plug it into the very first one. So I get x plus 2 times -5 plus 2 is equal to 0. I plugged in the -5 for the y and the 2 for the z. That's going to give me -10 plus 2, which is -8. I add the 8 to get it to the other side, and we get x is equal to 8. And so that is 8, -5, and 2 as a solution.